Hey everyone, and welcome back to The Explainer. So, today we're looking at a truly fascinating, almost unbelievable coincidence on the calendar. We're talking about June 26th, which is an absolute golden date in math history. And today, we're going to uncover exactly why.
June 26th. On this one single date, across completely different centuries, and in entirely different parts of the world, brilliant minds literally changed the modern world we live in today. It's kind of magical just how much history is packed into this one little square on the calendar.
So we're going to travel right across this timeline and meet these minds one by one. 1824, 1903, 1914, and 1951. Think of this whole thing like a giant detective story where every single clue is hidden right there in the math. All right, let's dive in.
Okay, our first mystery. Have you ever wondered how a message, or even the data for this very explainer, can cross the ocean in a split second? Seriously, why does it load instantly when the server is sitting thousands of miles away across the Atlantic? Well, that brings us to number 1, William Thomson, born June 26, 1824. You see, Thomson didn't just sit around studying equations on a chalkboard. He actually helped lay the 1858 Transatlantic telegraph cable at the very bottom of the ocean. And to catch the tiny fading electrical signals traveling across all that water, he invented something called a mirror galvanometer. Basically, it was a clever device that used a tiny mirror to reflect a beam of light, amplifying those super faint pulses. Because of this incredible work, he literally built the foundation for the high-speed internet cables that connect our digital world right now. Thomson famously believed that to truly understand a phenomenon, you must, quote, express it in numbers. You know something about it. By applying pure math to a physical copper wire, he gave us our first massive aha moment. The foundation of our modern digital lives? Yeah, it was laid over a century and a half ago.
Okay, still on June 26th, but now we're jumping way forward to 1951. Same golden date, but we're looking at a totally different kind of technology.
So tell me this. How does artificial intelligence, or honestly, even just your smartphone's keyboard, predict your writing style? How does it somehow just know what word you're going to type next?
Let's look at number 2. George Udny Yule, who died on June 26, 1951. Yule managed to connect two totally different worlds. He applied pure statistics to literary vocabulary. He analyzed things like sentence length and word frequency to find numerical patterns in how authors write. By mapping these patterns out, his study of words essentially gave us the exact mathematical blueprint for the modern AI text analysis and grammar checkers that we use every single day. He literally wrote the book on the statistical study of literary vocabulary, and in doing so, Yule proved a pretty mind-blowing point. Every sentence you type has a hidden mathematical fingerprint. Literature and mathematics are way more deeply connected than we usually realize.
Right, let's keep it moving. Still on June 26th, but now we're jumping backward to 1914. We're in a completely different country now, with an even bigger idea to solve our next mystery.
Is it actually possible to capture the blazing energy of a star inside a machine right here on Earth? I know, it sounds massive, cosmic, and basically like pure science fiction, right? But the crazy thing is, it's rooted entirely in math.
Enter number 3, Lyman Spitzer, born June 26, 1914.
So Spitzer developed this absolutely incredible concept called the Stellarator, using wildly complex magnetic geometry. Think of a shape kind of like a twisted figure-8 tube. He figured out how to trap superheated ionized gas, also known as plasma. His brilliant calculations pushed us closer to actually recreating the fusion power of the sun inside a machine. He really paved the way for the clean, space-age energy that scientists are still building toward today. When his paper quietly stated, "The magnetic configuration of the Stellarator is given," it represented a hugely awe-inspiring realization. I mean, we are literally learning how to build stars on Earth using geometry. How cool is that?
One date, so many incredible stories. Let's make our final jump on the timeline, back to 1903, to set up our last historical mystery for today's explainer.
Think about this for a second. How does a weather app on your phone know exactly where a chaotic, swirling storm is going to go? How can we possibly predict something so wild and aerodynamic?
That brings us to number 4, Walter Gröbli, who died on June 26, 1903.
Gröbli managed to map the exact mathematical motion of interacting fluid vortices. Basically, he solved the insanely complex equations behind how multiple swirling currents collide and spin.
His 19th century calculations were so precise, so on the money, that his thesis is actually still cited today when engineers design modern aerodynamic aircraft, or when meteorologists predict the destructive path of a massive hurricane.
Just as modern historians note, few will write a thesis that will be the subject of attention a century later. But Gröbli did exactly that. He cemented the idea that the chaotic swirl of a hurricane actually follows a strict mathematical choreography. It just goes to show that math governs even nature's wildest, most unpredictable forces.
So when we pull back and bring all these stories together, a truly remarkable picture emerges. We've got William Thomson, Walter Gröbli, Lyman Spitzer, and George Udny Yule. Despite living in completely different centuries and in entirely different countries, they are all forever linked by this golden date, June 26th.
Every single person we met today asked the exact same unifying question: what is the pattern hiding inside the chaos? And because they asked it, and because they used math to find the answer, our world today has the internet, AI, advanced weather prediction, and the blueprint for limitless fusion energy. The power of a single date is just truly remarkable. Thank you so much for exploring this with me, and I really hope this leaves you wanting to uncover even more of those hidden patterns out there in the world. See you next time.